Hello viewers and welcome to a new STM32 World video. I didn't call this a tutorial video, it is more a research digging into something video. What I'm going to talk about today is a follow-up on a couple of earlier videos that I posted as Unknown MCU. Which was basically digging into an MCU that seems readily available in China called STM32F402. Now the problem is if you actually try to look that up on ST's international website, it doesn't exist. If you try to create a CubeIDE project, STM32 CubeMX project with the STM32F402, it can't, it doesn't exist, and yet it seems readily available in China. Now, I was digging into this in these two rant videos, and my speculation, and this is pure speculation, is that this F402, while it is called F402, that is just a print on the box, and inside I speculated that this is most likely an STM32F401. Now, that speculation was in fact confirmed on ST's forum by somebody who says he's an ST employee that say that this is a CPU for MCU for the Chinese market, but it is in fact a 401 worldwide. So, well, I don't like mysteries, so what I did in the last video down here is I actually designed a STM32 World um, development board with this MCU on it. Now, the board itself was designed 100% as if this was a 401 and you could in fact just plug a 401 on it, but I merely changed the part number and put a 402 on it and checked what would be the result. Now, I have mentioned in a couple of earlier videos that GLC PCB has agreed to sponsor, at least in part, this channel, and I did an unboxing video mostly for fun. It's the worst video I have ever done. I promise I'll not do that again. Anyway, this was the result of the first order I put in. I have my STM32F402 development board. I have a micro SD card that you can stack up on this. I also have a standalone micro SD breakout board, and I have this LED board. This will all be covered in future videos. Today we're talking about this one, which I received from GLC PCB, readily manufactured. So let me show you. Let me go big on that one. I put a bit of masking tape over the LEDs. The LEDs are so bright they screw up my camera completely, and it still looks pretty shitty like this. But anyway, here's the board stacked on top of my ST-Link device, and the ST-Link device is connected to USB. Here we go, back. So let's start digging into what is this MCU. We have the MCU, it's hooked up to an ST-Link device, so the obvious choice would be to run stinfo.probe, dash probe, and wouldn't you believe it, it identifies as a STM32F401. It's really quite a vogue processor, right? It identifies as a, it is in fact an STM32F401, but it identifies as something else. Very modern, very modern. I like that. So anyway, let's try to dig a little bit more um, by firing up Cube Programmer. Let's see. And for some bizarre reason, that always end up not fitting my screen. Don't know why, but and a slope there. It gets very, very big, but let me make that a bit smaller. So here we go, STM32 Cube Programmer, and let's try to connect. And down here you will see it is an STM32F401 with 256 kilobyte of flash It's a Cortex M4, and well, it is empty because this is a brand new MCU. It has never been flashed. It has never done anything before. So it looks okay. Now, sometimes ST parts actually contains different memory, and a good exercise first would be to check if this is actually having 256 kilobyte of flash memory. That before I even start programming it. So what I'm going to do is I'm going to use a bit of command line magic. To do this, I am creating a file called data original. Block size 1 kilo and 256 of those. That should be 256 kilobyte of random data. So let me try to do that file. Now let's try to flash this file onto the device. Let's see if I can. Okay, ST flash, right, data oric, and we will write it at 80000000 like we always do. So let's try to write this file of random binary file of random data to the MCU. Oh, so okay, that explains. Let's see. There, we actually had it. So let's try to write that. Didn't work. Is that because I still have the cube programmer? Oh, that should work. Oh, we don't have that in the wrong folder. 206. I was actually on a different machine. There we go. So now it erased the flash on the board and it tried to write 256 kilobyte of data, and it verified, and jolly good, it says it's written. So let's try to read this data back. So we can do that with read. There we go. And I will read it into a file called data.read. Same address, same size. So now we are reading the file from the device, and we will end up with two files. We have the data oric and we have the data read. And they are both exactly the same size. Now let's try to compare those two files. We can do that with an MD5 sum data dot asterisk. There we go. And you will see that these two files are exactly identical. So in other words, we can write 256 kilobyte of data to this device, and we can read the 256 kilobyte back, and everything is perfectly fine. So next step, let's kill that one. I don't need that. Next step would be to actually try to do something. Let's do our basic blink on this. So in this one, I'll start completely from scratch because I don't have another project I could clone. So let's start an STM32 project, and let me just find where are we? It's supposed to be. It is actually an RC, right? It is the RC. So let's assume it's an STM32F401 RC T6. This one is a LQFP, LQFP 64, correct. 256 kilobyte of flash and 64 kilobyte of RAM. So let's try to start this project, and we will call this STM32 World STM32F402 Blink 1. That's a very good name for it. Let's start with that project and see what comes up. I might do a cut here because it usually takes a little bit of time first time, so sorry about that. My editing skill is not really very good. And there we go. We have a blank project. None of the pins are used. So let's start doing our usual stuff. I always go into the system core. I enable trace or serial wire, it doesn't really matter, but let's do trace since we have them. We have the SVO pin wire too. You don't necessarily have to do that. And let's go up here and say we are running with an external crystal. We go over to the clock configuration, and this is a 16 megahertz crystal. We are using the high-speed external. We are using the PLL to generate the clock, and it can run up to 84 megahertz. So let's put this at 84 and let CubeMX sort out the values, and there we go. So 84 megahertz. We have 84 megahertz on both the timer clocks, so all the timers will run at 84 megahertz, but we only have 42 megahertz on the APB1. I have to look into what peripherals hang off of that bus. I don't remember off the top of my head. So that was it. Let's do some first of all, let's do if we are going to write a blink, we definitely need a GPIO output there, and we could call that one LED. That is a good choice. Let's immediately go in and say, well, this is by default high, and it should be open drain. That is, it has been explained in an earlier video why I use these settings, but essentially the LED is powered from directly from 3.3 volt, and that means we need to sync data into the MCU to switch it on. So if the output level is low, the LED will be on, and vice versa. So that's it. Let's enable some serial output while we're at it, and I always go up to 0.0000000 is a good speed to run on this. So we have the UART over here, which is the correct pins for the settings I have here, and but that's pretty much all I want, isn't it? So let's try to, I'm sure I forgot something, but we can always go back and deal with that later. So let's generate some code for this. And there we go. We have the basic code. Now let me go over to my STM32World website. There's always a few things I don't remember, but down under STM32 development, I have my serial debugging page. Again, I can figure this out if I actually think about it a bit, but it is much quicker just to copy that redirect here. So first of all, we need to include std.io to have printf defined, and then we go down in our code 0 here and say this redirects printf to the serial port, and then we can go down here and after the initialization here we can say printf make a couple of empty lines starting F402 and a new line. There we go, and down in our loop, let's do our usual, it is quick enough to do. So first of all, let me define a couple of variables. We have now equals 0, next blink equals 500. We toggle the LED every 500 milliseconds. That will result in a blink every second. And next tick 1000. That would be a good start. In our while loop, we set now equals UV tick, what it's called, and let's do the quick one first. So if now is greater than or equals next blink, we do a hell toggle pin, and we toggle our LED port and our LED pin, and we do next blink equals now plus 500. That would take care of the blink. Now let's do the printout. So if now is greater than or equals next tick, next tick equals now plus 1000, and I just print out tick. That's about it. Now divided by 1000. I don't need the milliseconds. So that's about it. Let's find one of my consoles there, and let's start a terminal there. So now I show the printout from that. So let's try to build this project first. Our first project built for the mysterious STM32F402. It built no problem at all. Let's look at it. It takes 12 kilobyte of the 256 we have, 13 kilobyte, and well, let's try to flash it. So we click run up here, and let's look at the serial port. Oh yeah, first time you run you have to confirm these settings. They are all okay, except if you want to use this SVO port, you have to enable that on. That's it. So there we go. It is flashing, and there we have starting F402. So the first application running on an STM32F402. Now I have let's show the here. Can you see? Yeah, it is blinking. The blue LED is blinking. You see it there. I'm sorry about the quality of this. I don't know how to film LEDs. It always look washed out, and the colors don't pick up correctly. I am struggling a bit with that. I need to find a better way. One day I'll do that. So that was essentially confirming that the STM32F402 exists, and let me just show you, by the way, while I'm at it, if we go to LCSC, which is owned by the same company that owns the LC PCB, by the way, and that's why they use the same part numbers. So if you look in here, we can say STM32F402. Let's search for that MCU, and you can see down there it is available $1.60 if you buy one of these, but you get down, if you buy more than 160, you get them $4 a pop. If we look at the STM32, let's do 401 RC. Let's find that one. Now, heavily discounted. Here it's a hot, it says, so it's cheaper than normal. You get them for 224. So it is close to $1 cheaper than 402. Not quite $1 right now, but in most cases it'll probably be $1 cheaper. And as you can see, it works absolutely perfect. Now I'm probably I don't know if I'm going to talk anymore. I'm probably not going to talk anymore about this MCU. I'm just going to assume from now on it's a 401, and I have an extra development board with a 401 and I have 405. I'm probably going to make a few more of these in the future, but now I have two different I can toggle. I'm probably also still going to use my black pill F411 on occasion because I like the black pill. Actually, let's just, I said I didn't want to say anymore. Let's try to debug. So let's fire up the debugger on this board, and here we go. We can go a live expression. I want to follow the UV tech, and let's just run that and see what we go. And there you go. I can monitor variable, the debug work. I have absolutely no doubt that this is an original ST microcontroller. It is not a Chinese clone with a slapped up badge saying that it's an ST. It is an ST, and I'm sure it's an STM32F401. And it seems to work absolutely 100% as intended. So I think that's all I'm going to say about this MCU right now. Let me, it's, this would not have happened if it wasn't for DLC PCB. If you ever want to do a PCB project, go check them out. If you go on the STM32 World, there will be a link where there'll be a link down in the description, and that will give you some free coupons if you're coming from mine. You can also go to the website, and if you check the JLC PCB's page, and you can just click on their logo and you go straight to JLC PCB, and you can check how to order different. They are really quite good. These boards, where are we? No, it was here. This order, I put that in Monday. I can't remember what time, but sometimes during Monday, I put this order in with 4 different boards. And the following Monday, at about 3 o'clock in the afternoon, it was delivered at my door. That is quick. They made the PCB, they soldered all the components on. It's actually quite amazing that it's possible. It blows me away every single time I use them, and they don't make very few mistakes. So yeah, go check them out. Go check out JLC PCB. They have helped a lot with these videos, and I hope you enjoyed learning about the mysterious F402. As I said, I'm probably not going to make more videos about this unless I come across something that doesn't behave as intended, but I am going to use this board in future videos. As usual, well, please like and subscribe, or comment down below if there's something you don't like or something you wish me to look into. And as usual, have a wonderful rest of the day.